So this section is going to talk about the natural logarithm. And the natural logarithm is just a logarithm with base e, but you see it written here like this. You won't normally see them write it like that. Instead, they change the word to natural log, so that's an L and an N, because it uses the natural number as the base. But in your mind, you should understand that this is the same as this. So really, this is a big unit of review because it's going to cover everything we just covered, but specifically when the base of the logarithm is e. Okay. So this first, in example 13, these three things are asking us to condense them. So this is good review with your properties of logarithms. So remember, first, these out here can be rewritten as powers of what's inside of that logarithm. And then to combine two logarithms that are subtracting, they combine into one logarithm where you're doing division. And so this would be the natural log of 8 over x cubed. For part B, I would start with the same thing with this 2. So this will be 3 squared and then 8. To combine two logarithms that are being added, they combine into one logarithm where we multiply what's inside of those logarithms. 3 squared is 9, and 9 times 8 is 72. So this would be the natural log of 72. And then lastly, I'm going to do part C. So again, those exponential portions, using those coefficients. And then we're going to combine these two together using multiplication with the x and y base. And then the subtraction indicates division. So our final fraction here is going to have x to the 20th multiplying y to the 5th and being divided by z squared. And that can all be combined into that single logarithm. Example 14 focuses on solving log equations. Now remember, when we're solving log equations, we want to either set the insides of both logarithms equal to each other if we have logs on both sides, or we want to rewrite an exponential form. So when I look at example 14 parts A, B, and C, there is no log on both sides, so all of these are going to be candidates for rewriting. And I need to remember that the base of this logarithm is e. So when I go to rewrite part A, the base is e, 5 is the exponent, and x is what it would equal to. And this actually solved the equation just by rewriting it. X is equal to e to the 5th. In part B, it's ready to be rewritten. E to the 3rd power equals 6x plus 1. And then I need to isolate x. So I would subtract 1 and then divide by 6. And so in this problem, x is equal e to the 3rd minus 1 over 6. And then lastly, in part C, I would have e to the 6th equals 2x plus 1 squared. I would then square root this, giving me plus or minus e to the 3rd equals 2x plus 1. I would subtract 1. And divide by 2. Now, one thing I didn't do, and I'm going to go back and do right now, is I do need to check these answers. Check them in the sense that I know they cannot leave a negative or a 0 value inside of a logarithm. So like here, e to the 5th, if I plug that back into x, then I'm taking the natural log of a positive number, whatever e to the 5th is. So that's fine, okay? Here, this fraction, e to the 3rd minus 1 over 6, it would get multiplied by 6. So I'll just write this out here. If I multiply it by 6, the 6's will cancel, and then it has 1 being added to it. Then the 1's will add to 0. So I will have e to the 3rd inside of my logarithm. And e to the 3rd is not negative, and it's not 0, so that works just fine. And then lastly, checking this last problem, okay, notice that the last one has this. I actually don't feel the need to check because whatever I put in here, I'm squaring it and then taking the natural log. So whether it was negative or positive, it would be squared before I took the log, which means as long as it's not 0, it would be fine. And it's not 0 in this case, so that's going to check. Both answers. There are 2 there with that plus or minus. So lastly, we're going to solve these equations with e in them. And remember, these are exponential equations, which means we can either rewrite both sides with the same base, or we can solve using logarithms. It would be difficult here to rewrite both sides with the same base because not both sides have an e. So we're probably going to rely heavily on taking logarithms. In example 15 part A, it's already been isolated and it's ready to rewrite. So it would be log base e, which we call the natural log, of 24 equals x plus 3. And then to isolate x, we would subtract 3 from both sides. And we would get that x is equal to the natural log of 24 minus 3. For part B, I would first want to divide by 5. So I would have e to the negative 3x equals 9. I'm not going to rewrite 9 with a base of e. That doesn't seem very possible for me personally, so I'm going to use a logarithm. So I'm going to rewrite log base e, or natural log, of 9 equals negative 3x. And then I would divide by negative 3 to finish solving this, and I would have that x is equal to the natural log of 9 divided by negative 3. And here we don't worry about checking answers giving us negatives because x was in the exponent in all of these equations, and you can plug anything into the exponent. So if your algebra is correct, there's no chances of extraneous solutions and your answer should be fine. For part C, to isolate, we're first going to add 8. So we'd have 2e to the 5x power equals 38. We would then divide by 2. So we'd have e to the 5x equals 19. And now we either need to rewrite them with the same base, which when I'm using e, again, that's extremely difficult unless there were already built-in powers of e on both sides. So I'm going to rewrite this in log form. So it would be log base e, which is natural log of 19 equals 5x. And then I'm going to divide by 5. So x is equal to natural log of 19 divided by 5.